All right, let's go ahead and try and figure out all the key details of this function and then sketch its graph. So we are already in vertex form, which means that we get the vertex for free. Remember that within the parentheses, you always have to change that sign. It's always backwards. So the vertex will be at +1, +2. So that y-coordinate is the plus k out at the end. So that we can get without doing any work at all. This is the beauty of vertex form. We also want to find the x and y-intercepts. So let's get the y-intercept next. And the most important thing to remember about y-intercepts for any type of function is that the way you find them is by letting your x, or in this case your t, be 0. So we need to find m of 0, which is 1/2 of 0 minus 1 squared. 0 minus 1 is -1. Plus 2. I kind of can't see my own thing, but I think it was a plus. Yes. Which ends up being what? -1 squared is 1, so 2.5. So 0, 5/2 is my y-intercept. The last one I want is x-intercept. And again, this isn't a form where you just get that for free, but even if you forget everything about your forms, what I want you to remember about x-intercepts is that you get them by setting y equal to 0. And since we're in function notation, that means the entire m of t gets replaced with a 0. And then we can solve from there. And this should look like our solving with square roots. We don't even have to complete the square. That part's done. So I'll subtract the 2 from both sides. Just doing my reverse order of operations. And then I need to get rid of the 1/2, so I'll multiply both sides by 2. And the next step would be square root both sides, so plus or minus the square root of -4. But at some point here, I hope you notice that this is not working. There's no solution to that equation. And what that means is there are no x-intercepts. And that is very possible for a quadratic. It's never going to be true if it's factorable. If you can get it factored, it has x-intercepts. There's a direct link there. But here we have something that has a vertex at 1, 2. And if we look, this number out in front tells us if it opens up or down. We also know that it opens up. So if your vertex is above the x-axis and you open up from there, you're not going to have any x-intercepts. So let's place that vertex at 1, 2. Remember, that's your vertex, so this is your axis of symmetry. I don't use this vocab a ton, but it may come up a little in your homework, and I just want to mention it. So you don't have to draw that line for me, but that vertical line x equals 1, that should split your parabola into 2 perfectly matched halves, mirror images of each other. So wherever your vertex is, remember that's going to be perfect mirror images on either side of that. All right, and then I did have a y-intercept, but also remember that if you don't have enough points and you don't feel like you can figure out what's going on, you could always plug in a couple more values. So for example, maybe I want to know what m of 2 is, just to at least have 1 point on that side. And that would be 1/2 of 2 minus 1 squared, which is just 1 again. And that is 5/2. And notice that was exactly what symmetry would have told me. So if I go 1 to the left of the vertex and my y value is 5/2, then when I go 1 to the right of the vertex, my y value should also be 5/2. And we could maybe snag a few more if we want to make this really spot on, but I actually think we probably have a pretty good idea just from that. This is a little bit with the 1/2 out in front, a little bit shorter and wider than some of our parabolas look like, but otherwise kind of our typical shape. Thanks for watching.